Okay, question number 10 from lesson 5 has two equal forces, equal magnitude at 60 degrees to each other. So if we draw this out algebraically, it's always easiest to draw one of your vectors. When they don't give you an orientation, it's always best to draw one of them along the x-axis. Just makes your math a little bit easier. Your second vector then is going to be there, and there's my 60 degrees. And what we know is, we know the magnitude of the resultant is 30 newtons. We want to find the magnitude of u, which is equal to the magnitude of v. So both of those vectors are equal in magnitude. So we need to figure out where that resultant's going to be heading. Now, for some of us, you're going to be looking at that and saying, well, if the two vectors are pulling equally, well, then it's going to split the difference, and my resultant is going to head in that direction, which is an angle of 30 degrees. So for people that don't see that right away, let's talk about it geometrically for 1 second. If I take my vector u and I slide that vector v, which was there originally, I slide it to its new location right here, so I have head to tail addition. What you'll see is that 60 degrees still is right there. That means the internal angle there is going to be 120. When I draw my resultant, we have an equal or an isosceles triangle because we know the magnitudes of u and v are the same. That was already given information. Makes that isosceles, which means we have 60 degrees left inside. 180, take away 120. We divide that in half, and each of those are going to be 30 degrees. Okay, so this is extra. I don't really need to see this. This is just justifying my thinking. So if we take this and add those vectors together, we know the u vector is the magnitude of u, and it's going to be I, no angle, plus no j, because I've drawn it such there is no y component. The v vector, well, I already said that u is equal to v, so I'm just going to replace it right now. I'm going to say the magnitude of u cos 60i plus the magnitude of u sine 60j. I'm going to add those two vectors together, and when I do that, I get a resultant that's equal to 30. That was part of the question. It was given. I already know the magnitude, and we know where it's going to end up based on kind of our reasoning there. We know it's going to be in the top right quadrant, so to be cos 30i plus 30 sine 30j. Now, in order to solve, all we're looking for is the magnitude of u or v. And when I look down my columns here, I look and see that there's only one unknown in that particular column, so that's probably going to provide me with the easiest way to solve this. So that means that I know that the magnitude of u sine 60 will have to be equal to 30 sine 30, since that's the only one that's providing that y component. Dividing both sides by sine 60. Oops. Beautiful looking S. Magnitude of u then is equal to, and just using my calculator, 30 sine 30 divided by sine 60 gives me approximately 17.3, and I believe we're working in newtons, which is equal to our magnitude of v. So therefore, the magnitude will be 17.3 newtons for u and v. If you have any questions with that, just let me know, and hopefully that clarifies any problems you had.